Let us look one more example of Lagrangian equation. So this is inclined plane. Here this box is M1 big box. It is slides on a horizontal smooth surface, and M2 slides on a smooth inclined surface of a plane of mass M. Thus, the system has 2 degrees of freedom and hence to need two generalized coordinates. This is M2, okay, M2 this way. Let x1, this is the x1 distance, and x2, this is x2 distance, okay. These are represented displacement of M1 and M2 from their origin. This one is O origin, this one is O prime. This is horizontal smooth surface. In case if you are confusion, this one is horizontal smooth surface. This is smooth inclined surface. This one, okay. Velocity of M1 with respect to velocity of M1 with respect to origin O is x dot 1. Similarly, velocity of M2 with respect to O prime is x dash 2. So I'm going to remove these semicolons, okay, right. Now velocity of M2 with respect to O equal to, so how we can get velocity of M2 with respect to O? So we need to draw one trigonometric diagram. So this is our diagram, okay. Then just wait. Hmm, okay. It is better, right? Yes, right. So here I'm going to give this one is x dot 1, okay, x dot 1. It is better to give here, this one is theta, this one is also theta, and this is the velocity, this is x dot 2, okay. The velocity of m1 with respect to O is x dot, with respect to O prime is x dot 2, right? So the sum of these two velocities is this is our rough diagram to get this information. These points are very important to find the equation of motion of inclined plane, okay. So velocity v with respect to O. Here I'm going to take, okay, not the O. X dot 1 plus x dot 2. So therefore, velocity square equal to x dot square 1 plus x dot square 2 plus 2 x dot 1 x dot 2 cos theta, right? The kinetic energy of whole system observed from O is kinetic energy T equal to 1 divided by 2 m1 x1 dot square plus 1 divided by 2 m x2 2 dot square. So we know this velocity, we don't know the x1 dot square value. This is better to write this one here itself, right? Velocity m2 with respect to O. Okay, this is x dot square. This is x dot square, or I'm going to write here x dot square to velocity of m2 with respect to O v, or x dot 2 square, right? Kinetic energy T equal to 1 divided by 2 m1 x dot square plus 1 divided by 2 m. We need to write all this information. X dot square 1 plus x dot square 2 plus 2 x dot 1 x dot 2 cos theta. So this is our kinetic energy term. The potential energy of system is due to the position of mass m2 with respect to the horizontal smooth surface only, not vertical smooth surface. Okay. So therefore, I'm going to give one more diagram here, or else I'm going to write this information. Just give me this. Potential energy of the system is due to the position of mass m2 with respect to horizontal smooth surface only. And hence, so it is better to draw one more diagram. This is x2, this is x total, this is x prime. Okay, x prime. So how I derive this information here? If you go and look this diagram, so this is total displacement is x, right? This one is x, right? Total displacement of the system. Okay, from here to here, x, right? Then from here to here, this is x prime, this is x2, this is the x, and this is the diagram. Okay, now we are going to find one important information here. What is the sine theta value here? This is our theta. Okay, this is our theta. Sine theta equal to x prime divided by hypotenuse x2. So let us look this potential energy V is equal to mgx. We need to find what is x value here, right? So therefore V equal to m2g, okay, height h minus x2 sine theta, sine theta. Okay, this is total height, right? This is total height h. This portion is x2 sine theta. Okay, x2 sine theta. Therefore, we know potential energy term right now. This is our potential energy term. This is our kinetic energy term. Now we can easily derive our equation of motion of inclined plane. Okay, let us take our Lagrangian L equal to T minus V. So this is Lagrangian. First we need to take Lagrangian. So what is T value? T value is 1 divided by 2 m 1 x dot square 1 plus 1 divided by 2 m2 x dot square 1 plus x dot square 2 plus 2x dot 1 x dot 2 cos theta minus potential energy m2g h minus x2 sine theta. So this is our Lagrangian. Now we can derive anything, right? So here this is complicated system. We know the Lagrangian is represented two type of coordinates here. I mean two generalized coordinates. One is x dot 1, another one is x2 dot. First I am going to write one coordinate system, that is x dot 1. Okay, so Lagrangian equation of motion d by dt, partial derivative of Lagrangian divided by x dot 1. This is our one generalized coordinate system. Okay, again we need to find other coordinate system also. 0. Now we want, from this information we need only dou L divided by dou x dot. We need to differentiate with respect to x1 dot, I mean velocity of first particle, I mean m1 particle. So this one is, if you look at this information clearly, it is partial derivative of L divided by dou x dot 1. This one is derivative, this one is derivative, this one is 0, this one is constant, this total term is 0. Okay, 2 gets cancelled. First term will got m1 x1 dot is there, plus here let's go for breaking point. This one first, 2 gets cancelled. M2 x dot 1, this portion is 0. This one plus m2, 2 gets cancelled, x dot 2 cos theta. Okay, now we want to only dou by dou x1 term. If you look at here, there is no x term here. Okay, I mean x1 term, not x term. X term is there, x2 is there, x1 term. So this one is 0. Therefore, equation of motion, one equation of motion m1 x dot 1. this portion d by dt, we need to write m2 x dot 1, okay, plus m2 x dot 2 cos theta. This term is 0, then this one is 0. So therefore apply this one, this m1 x double dot 1 plus m2 x double dot 1 plus m2 x double dot 2 cos theta. This is our equation of motion. So if you rearrange this equation like this, x1 double dash plus m2 x2 cos theta. Okay. Similarly, if you derive with respect to d by dt another coordinate system, if you take x dash 2 minus partial derivative of L divided by x2 equal to 0, you will get this equation definitely. m2 into x double derivative 2 plus x double derivative 1 cos theta minus m2 g sin theta equal to 0. These are the important equation of motions of the inclined plane system with respect to m1 with respect to m2. So as we said initially, if you want to calculate this type of calculate, we need to know first how many coordinates needed to describe the system. One is horizontally moving, another one is vertical smooth is moving, right? Inclined smooth plane. So therefore we need to generalize coordinates. Those are x1 dot and x2 dot. So I got two different equation of motion. Okay. So from this information I'm going to write x1 velocity of the system minus m2 x double 2 cos theta divided by m1 plus m2. So from this information, x1 double dot equal to g sin theta minus x double dash 2 divided by cos theta. So it is better to give equation number. This is equation number 1. This is equation number 2 for our convenience. Okay. I'm going to give equation numbers. Later we use these equations. These are the very important equations. Okay. This is equation number 3. This is equation number 4. So from equation number 3 and 4, we'll get this equation. Very important. Minus m2 x double dash double derivative cos theta divided by m1 plus m2 equal to, from these two equations, right, g sin theta minus x2 double derivative divided by cos theta. So I want to rearrange this equation. Okay, the first step, minus m2 x2 double derivative cos theta square equal to m1 m2 g sin theta minus m1 m2 x double derivative to 2. So if you rearrange this equation like this, finally you will get x double derivative 2 equal to m1 plus m2 into g sine theta divided by m1 plus m2 minus m2 cos square theta. So x double derivative 2 equal to g sine theta divided by 1 minus m2 cos square theta divided by m1 plus m2. Okay. So if you substitute this x double derivative 2 in equation number 3, we will get the x1. So here I'm going to substitute. See here x double derivative is there. From this information I got x2 double derivative. Substitute this x velocity of second particle here. Then you will get velocity of first particle. And this is the equation of motion of inclined. X double derivative 1 equal to minus g sine theta cos theta divided by m1 plus m2 divided by m2 minus cos theta square theta. Okay, so this is all about inclined plane. So quickly, if you look at here, first we need to derive the potential energy and kinetic energy of the system. Then we need to substitute Lagrangian first, then Lagrangian equation. So Lagrangian means Lagrangian function L is equal to t minus v. This is the Lagrangian. I have seen this type of questions in state level eligibility test examinations. Some objective questions they are asking what is the Lagrangian of the system. They are giving options. Lagrangian L is equal to t plus v, Lagrangian L is equal to t minus v, and they are giving Lagrangian equation of Lagrangian equation. Many people are giving option Lagrangian equation. They are clearly asking what is Lagrangian, not Lagrangian equation. So this is the Lagrangian equation. This is the Lagrangian equation. This is the Lagrangian function. Okay, Lagrangian. They are not saying any Lagrangian. Lagrangian. Simply they are giving word Lagrangian. Identify the following equation. What is the Lagrangian? They are giving one option L equal to t plus v, another option L is equal to t minus v, another option Lagrangian equation, another option they are giving or Hamiltonian H is equal to t plus v. Okay, so many people are giving this is the Lagrangian equation. They are giving this option Lagrangian equation, but correct answer is Lagrangian L equal to t minus v is the Lagrangian. They are asking Lagrangian, not Lagrangian equation. So this is the correct answer. Okay, so this type of complicated system we need to describe two generalized coordinate. One is x1 dot, another one is x2 dot. So therefore we need to find the velocity of m1 with respect to O and velocity of the second particle. Okay, so this is all about inclined plane.